So first of all, who here is working on, or who here is working for companies who have systems in the cloud or are moving? So it's probably certainly a majority, about 80%. So I hope this isn't intended to put you off. You know, it is possible to do things securely in the cloud. It just requires a bit of a different approach. Just a slight addition to the comments. I do work for QA as an associate trainer. That is one of the things I do. But my main job at the moment is for a financial services organization, and that's a sort of. But it's still an important part of what I do as well. So what I'm going to do is today is I'm going to demonstrate. It's always dangerous trying to do live demos, so I'm going to do some live demos. We'll see what happens. I'm going to do some demos of 3 different cloud security issues. And these are all issues which I've, real-life issues which I've encountered working with different customers. So they're not theoretical things. And then for each of those, I'm just going to look at why the issues happened. And then talk about how, as a profession, we should prevent these sorts of cloud security issues and others from occurring. And I'm going to look at that when we get onto that section. I'm not just going to look at it from a technical point of view, because technology is part of the solution, but also from a sort of training, cultural, and organizational point of view as well. So that's what I'll be doing. So I'm going to go straight into the first issue, which I came across, as I say, at one of the organizations I was working with. And this relates to identity and access management in AWS. So I'm guessing that of AWS, Amazon Web Services are the market leader in public cloud services. So I'm guessing, I won't actually ask in case it's confidential, but I'm guessing that of this sort of 80% or so of you that said that you were working on cloud or migrating to the cloud, I'm guessing that probably quite a lot of those are actually AWS. And while the examples I'm giving, or 2 of the examples happen to be AWS, it's not to say that AWS is any less secure than Azure or Google Cloud Compute. All of these platforms can be implemented securely. It's just a case of doing it, the right way. So for those of you, So for those of you who are not so familiar necessarily with, let me just get this on here. Okay. Right. Okay. So this is the AWS console. So when and I've logged into one of my accounts. This particular account is called Celidor. That's just the name of my company, so I've named this. When we interact as administrators with cloud services, you could do this via the portal, which is a web GUI, and that's a good way of visually seeing what's going on. Most organizations, for any deployment, would do that through infrastructure as code and do that programmatically. But from the perspective of just simply seeing what's going on, it's useful to use the portal. So let's just make that. So one of the services within that AWS provide, and you can see that they provide, many different services. Just expand that a bit. One of the services they provide is identity and access management, which, from a security point of view, is immensely important, as you can imagine. So in this particular account, you can see, and typically an organization would have at least one account, but maybe 4, 5, 10, 100 accounts, depending on how big they are and what they're doing. They might have separate accounts for production, staging, development. they might have different accounts for different types of applications to provide separation. But anyway, within an account, this account, you can see that I've set up users. So I've got multiple users, which you can see here. So lots of users. Some are users for the console. Some are users which have keys attached, so will be for programmatically deploying and configuring infrastructure. So I've got lots of users. And you can also see that users can be members of groups. So here's a user, a member of a particular group. And then the group has particular policies assigned. And as you can imagine, the policies give permissions for doing different things on AWS. So that's that sort of concept. So users, groups, policies. And then the other sort of, another feature of AWS Identity and Access Management is roles. So roles is, and we could see a role, as it says, so if we look at one of the roles at random, doesn't really matter. A role is a way of temporarily granting certain access and certain rights to a service principal. So in this example, there's certain rights to do certain things defined by these policies, and these are given to whatever is assuming this role for a period of time, in this case, an hour. So it's like a token, a secure token, which then allows certain access for that period of time to do certain things. So the roles can be assumed by users, like human users, but also they can be assumed by objects or devices. And in particular, in this example, there was a need for a server, a virtual machine within Amazon Web Services, so that's within their EC2, Elastic Cloud Compute Service, to assume a role so that it can itself programmatically do things in AWS, like access S3 buckets or make changes to Route 53 DNS. So, and that's a very common scenario. That's not at all unusual that we need to give permission for a virtual machine in AWS to access different services within AWS outside of that virtual machine. That's quite common. So, so in this particular organization, I came in and there was sort of production systems in place. This particular project had been going for probably 9 months or so without a lot of involvement of security. I sort of joined in a sort of DevSecOps role embedded into the DevOps team. And one of the things that I started doing was reviewing the code that was used to build the infrastructure. So, so one of the things which I sort of came across, if I can, so hold on a sec, where am I? There we are. You know when you've got like a left screen and a right screen, and then they're the wrong way around for the mouse? That's what I was just working out. Right, so yeah, so one of the things I was looking at was the policies for the servers to assume roles. So the policy which was assumed is sort of shown here. So, and bear in mind, all of this is written programmatically. So what this is really saying is that whatever assumes this role is allowed to do certain things to S3 buckets. And I have anonymized this, to slightly, well, with the names of the S3 buckets, but the principle is, very representative of what actually happened. So S3 bucket permissions at the top. Then there's certain S3 buckets which are allowed to be accessed, including some which actually did have -secrets as the name, believe it or not. And then you can see also here that there's an allow EC2:*, which means any action to do with EC2, and resource star. So the server is allowed to really do anything on EC2 within, well, anything within, whatever assume this role is allowed to do anything on Elastic Cloud Compute, which is Amazon's web services infrastructure as a service within this account. So that's the policy. So that looks okay. I mean, it may be, it was perhaps a bit overly generous. It could have been tightened up, but it didn't look sort of catastrophic. And then also associated with that, if I, again, remember to go the other way, was an assume role policy. Oh, I can just see that here, can't I? Assume role policy. Yeah. So this was the policy which then allowed a service principal to assume the policy. So can anybody, does anybody know, or can anybody work out what, or guess what action, what that might imply? Sort of. I mean, yeah, it's the star is the suspicious bit. So what this actually means, it means where it says effect allow and then principal AWS star. So this is the principal which is assuming the role. So that actually means that any service principal anywhere in AWS from any AWS account is allowed to assume that policy. So that really means that anybody could take over this production system if they had an AWS account and knew what to do. So I thought, well, I better correct this. So I flagged it as a high-risk issue, corrected it. And so I corrected it by working out what it should have said. And what it should have said is sort of this. So this says service ec2.amazonaws.com, which the way that AWS policies are derived means that it's only virtual machine instances within that account are allowed to assume this policy. So quite a straightforward change. So I made the change. So as part of the the DevOps team, checked out the code, made the change, went through all the CI/CD testing, and that was all then merged and fine. And I thought, right, good, job done. And then what then happened was, although that code was released to the sort of dev branch, it wasn't then promoted into the production system. And that was for reasons completely nothing to do with this. Waited a week or two and thought, well, this is quite serious risk. We need to do something about this. So I thought, well, what I'll do is then demonstrate to the senior management what this actually means. So rather long preamble, so now I'll do the actual demo. But it's important to give the context. So, right, so the sort of demo that I did was effectively to do this. So I've sort of simulated it. So what I did was I've set up a completely different AWS account to simulate the production system. And what I can then do is sort of go into here, and I can then do switch role. So what I'm going to do now is switch role into a completely separate AWS account from a separate organization. And all I need to do is put in here the name of the account and the name of the role, which I've done before because I was testing it. And then I do switch role. So it's literally that easy. So now you can see there's a sort of pink thing up here with the, so that shows that I've assumed a role into this other account. So if I look under Identity and Access Management, so for example, users, you can see I don't have permission to do anything with users, so that's something. But then because of that policy, which I'm assuming, if I go into EC2, which is the infrastructure as a service, you can see, well, I can actually see everything. So now what I could then do, for example, I mean, in the real system, there was 100 production servers, obviously not just one. And this bit I didn't actually demonstrate. But I could easily, for instance, terminate an instance that could be a production system. I could, so that's got rid of that. I could launch a new instance, quite easily that's under my control. And then, also because I didn't actually show you this, but also because there was also access to route 53 and permissions for route 53. I could also then redirect valid domains to my server, or I could do Bitcoin mining from 100 servers or whatever. So, so that's the first issue that I wanted to demonstrate. So just going back to the PowerPoint presentation. Over here now, aren't we? Okay, so what I did actually was then to do some screenshots of this, of what I just did with the real production system, put it in a PowerPoint presentation, sent it to all the senior managers in the company, and and then it was fixed within 3 days. So that was job done, which was good. So I've demonstrated this. I'm not going to go through that again. And you can see, all that went wrong was whoever coded this in the first place, probably, I'm guessing, because they weren't actually with the company anymore, what they probably did was just do a Google search on how to assume a role. It probably came up with that one, and then they used it, not really understanding the implications. I'm guessing. I don't actually know that. So that's that one. So second issue, everybody's favorite issue last year was S3 buckets. And again, just to emphasize with AWS, it's not that they're insecure. You just have to configure things properly. And similarly, all the other cloud services, have their own equivalent of S3 for storage. So this particular one that I've just brought up is a Dow Jones issue, 2 million data. 2 million users lost their data due to a configuration error on S3. And there are many, many other examples, as I'm sure you all know. So just to sort of give you an illustration, really, of how easy it is to sort of misconfigure and access S3. Right. So I'm going to show you that. So what I'm going to do is, I've actually used my other account for this one. We don't need that anymore. So, right. Okay. Right. So what I've done here is I've set up an S3 bucket. Now you can see AWS put in various improvements over the course of last year because of all of the publicity about different issues. And one of the things that they did at some point last year was they've now introduced this orange, in the console, they've introduced this orange public thing, which wasn't there before. And if you have got any public S3 buckets, then, which in this case I haven't, but if you have, then it would actually show that next to the bucket, just helpfully, so that you know if you log into the console. Bearing in mind that quite a lot of developers and DevOps won't ever use the console, so it's not that evident in code. Anyway, so they've done that, which is very helpful. So I've created a couple of buckets, and I've got one here called CPMS3, and I've got one file in there, which is called passwordfile.csv. And if we look at the permissions for the bucket, you can see here that, as it said, it's we've got everyone, and everyone hasn't got any permissions. So it's not a public S3 bucket. So let's just see if we can access that file. So it's quite helpful. So Amazon have got a very straightforward naming, a straightforward way of getting access to all the objects by the web. And what I'll do here is just open up a new tab, and then, do this. So I want to do S3. So S3. So it starts S3, then you do the hyphen, then you do the region name, which is EU-West-1. Then .amazon aws.com / and then the name of the bucket, and then the name of the object. So that's quite easy. And I should have actually used a different browser, but it doesn't actually make any difference. There's no authentication here. I'm not authenticating anyway. You could do this on your phone, if you want to get this. So, right. So .csv. Okay. So just downloaded the password file. So any ideas why I was able to download that, and why any of you could download this password file if you really want to know Bugs Bunny's password? Anybody got any thoughts as to why I was able to do that, even though it said it was
individual permissions on the object itself?
Yes, nice. Yes, exactly. So that's good. So if we were to go in here and then look at the objects on the permissions, then I have given access. So you might think, well, why would anybody do that? That's a weird thing to do. But actually, in the organization I work for, a DevOps person created a public S3 bucket. I then noticed that, got it, and got him to make it private. He then made it private in a manually, I think, but then didn't change the objects within it. So this was something that actually happened. But it's just illustrative. And there could have been other reasons as well. Like I didn't go into it, but you can also use JSON-type policies for them as well. It's very easy to get this wrong. And the only way of really testing it would be to look at every single object, and for every single object, try and get to it by the web, the public internet. That would really be the most reliable way of doing it, I think. And in fact, AWS have introduced, by the way, a whole load of tools and services to help with this, such as Macy to discover data in S3 buckets, and as have many other people as well. Right, so that's the second issue. And conscious of time, so I better speed up a bit. Where are we? Right, so back to the presentation again. Third issue is sort of an old favorite, really, once I get this back on the screen. Present view. Third issue is keys in GitHub. So I showed you various user accounts in AWS. They were associated with, some of them were associated with people, so they would have had usernames and passwords. We might use multi-factor authentication. But when deploying programmatically with AWS, you use keys. And again, it's a similar sort of thing similar for Azure Service Principals and Google Cloud Compute. And those keys, if they're lost, can be very damaging. So as an example, and this is not particularly to pick on this particular company, but it's just an example where somebody committed a key to public GitHub, which is a public code repository, accidentally, and I think this happened, unfortunately, on a Friday, and then when they came back in on Monday, there was a bill of $64,000 from people presumably mining Bitcoin or whatever. Fortunately, this particular account that was compromised was a development account, so didn't actually have customer data in, fortunately. But and this has happened in organizations that I've worked with. So one of the projects I was working on, a developer did exactly the same thing, accidentally, git push. That's all it takes. Only to git push, that's all you need to do, to a public repository. Fortunately, in that case, AWS has introduced very prompt auditing and checking. I got notified within about 5 minutes and then deleted the key straight away. So fortunately, it was quick enough, not to do anything. But it is a common issue. That's a couple of examples. That's my 3 examples. And I've just got a bit of time left to talk about how to oops, what am I doing? The wrong thing. How to try and prevent. So if we go back again to the presenter view. So yeah, if you think about why the security issues happened, I mean, it's easy. In each case, you can look at technical aspects, but culturally, in the particular organisation where these issues happened, there was sort of 30 to 40 DevOps and sort of cloud ops people, fairly geographically dispersed. Agile development teams, this is not uncommon. 2-week sprints. So, I mean, I'm assuming some of you are probably used to working in an agile way, others might not necessarily be, but the idea is that each DevOps person would pick up certain stories during the sprint and then deliver those by the end of the sprint. So with that much going on, it's very hard to necessarily pick up the sort of errors which I've just illustrated, because all it takes is one misconfigured line of code. So that's sort of the challenge. And also there was some manual configuration as well. So how can you actually prevent this? Well, technically, there's things that we can do. So we can put in policy as code. So for instance, in Azure, they have Azure policies. AWS have a certain amount of policies that can be introduced. We can put in security tests in the continuous integration and continuous development pipeline. We can do security scans. So, so here's some examples of security scans. So if I do, let's try and see what I can do here. Make that a bit bigger. So if I just do a quick scan on the account which I've just been looking at, I'm going to use NCC's Scout 2 tool, which is open source, i.e. free, and very good. To save time, I'm just going to look at one service. So what I'm doing here is I'm just doing a scan to review the security of this AWS account. But in this case, just looking at IAM, Identity and Access Management. So you can see here, I've identified various issues. I won't go into what they all are. Some are fine, green. Some are problematic, red. I mean, it's important not to think that just because you've got everything green, it doesn't mean that everything's absolutely fine, because these tests, they're only code. I mean, they're a very good set of tests, but they're not completely comprehensive. But it's a very good start running tools such as this. Similarly, on the similarly on the repository side, I can do something like this. This uses another open source tool, GitHub, to look at keys that are to look at a code repository and try and search for any confidential information that might be in that repository. So I've just searched my own repository for any information. So if I just have a look at that, let's see what we found. That's 9393. Okay. So you can see here that I have actually picked up, in this case, an AWS secret key, which you could try using because I've deactivated it. So, so there are technical things that we can do. There's some examples. I can talk for a lot longer, but I'll get in trouble, so I won't. And you'll miss your coffee, which is even worse. So, we can do. So we can not only put in security scans, but continuous compliance. So a complete solution should include prevention, detection, which is policy, detection, such as what I've showed you, and also enforcement. So there's techniques for continually enforcing as well. So that's really on the technical side. On the training side, there's a great deal that we can do. So I've developed a training course for QA, on cloud security, week-long course, which is certified by GCHQ, that goes into more detail on a lot of what we've just covered, and a lot of other subjects as well, such as serverless and Azure. But equally, short lunch and learn sessions with DevOps can be very valuable. So training is important and helpful. Culturally, it's important to prioritize security when it comes to deciding what resources to apply to, to what aspects of the project. And finally, organizationally, separate security departments with a separate CISO organization and an agile DevOps team doesn't work. I've seen it in several different places. This security team just end up being blockers. What actually works is embedding security specialists and DevSecOps into the DevOps team so that they go to every stand-up and take part in every sprint. So I'm being told to wrap up, so I'm going to wrap up. Thank you very much.
We have a couple of minutes, I think, for questions, if anybody does have any questions. No, you're all too
Everybody wants their coffee.
Eager to get to coffee.
No, go on.
Right,
we'll do this quickly, don't worry.
You've got half.
Things like unit tests and stuff to test for sort of security things as well. So like automated testing as part of the sort of DevSecOps to help people deliver secure code.
Yeah, so the question there was about automated testing and unit testing. So absolutely. Yes, I've somewhere got an inspec sticker on my laptop. But yeah, testing is great. So the CI/CD pipeline should include lots of security testing. Different types of testing. So we could do inspec for unit testing. We could use solutions like Veracode, check marks, etc. for application level testing. We can have integration tests. We can also do so for example, anybody who uses HashiCorp Terraform to deploy code could use Sentinel as policy as code. So there's loads of things we can do along those lines. So yeah, absolutely. Just sort of ran out of time to talk about all of that. But yeah.